we'll see what is the what is the control loop Oh, today you have heavy class of FM. So I think that is why I'm waiting. So what is the control loop of feed forward control? How many hours this FM is running from us? Very long, no? So what is the control loop of feed forward control? So what is the control loop for feed forward control? So we have discussed yesterday what is feed forward control is. So this is LM, LC, LSP. LSP. Now, sorry, this is feedback control. What is feed forward control is? We measure the set pointer. This is what is feed forward control. Can you draw the control diagram for this one? Can you try to draw the control diagram? What is the control diagram? Try to draw. We have drawn it for feedback. see, this is slightly different loop. So this y is my response. In the previous, this you have to follow as it is. There, this is slightly difficult to understand. So I'm trying to explain it slowly. So what is my response is level is my response. Your level get affected by 2 points. One is your final control element opening. Suppose if you open the valve more, the level will go down. If you open the valve little slowly, then the level will go up. So you have a disturbance. Disturbance is going to affect on my response something like this. So D into GD. What is D into GD? Yesterday we have stated, let's say this is my level. My disturbance is going to affect my level something like this. D into GD. Then you are opening the valve something like this. Your opening of the valve should be minus D into GD, so that your level will never change. So how do you do this one is, you have the transfer function of the process. So you have the transfer function of the process. So in the transfer function, if the input change is step input, just put the step input change. Just put the step input change and then put the step input change and see the how level is building up. Accordingly, you have to open the valve. So this is D into GD is, how do you understand D into GD is how level builds up, with the disturbance. What is minus D into GD? This is opening of valve to counter the disturbance. Opening of the valve to counter the disturbance. Have you understand? So the response here should be minus D into GD, so that the Y will be always 0. Y is 0 means the level is, this is deviation variable. So my deviation variables is always 0 means your level is maintained at a particular point. Just understand up to this point. Means your value is at steady state. So does everybody understand DZD and minus DZD? See, y should be always 0. That is where the response is constant. Now, what is affecting the GF? GF is coming from the process. So from the process, you have the controller. Then this is my set point. Let's say set point. Now, what is it that you are measuring? You are measuring your disturbance. Your measuring disturbance will go to compare with the set point, and then you will GF stands for, let's say this is G1. This control loop is like this only. You have to, I'll tell you, this is slightly, as I said, this is slightly confusing. G1. This is my set point. So set point. So basically you follow this one. So this is my disturbance. This is my disturbance. You are measuring the disturbance, that measurement disturbance, and you have a set point. There is some modification here. We'll go to here, and then this will be going to the controller. Controller will go to the process, and process will open the final control element. Clear? So final process control element. Or let's say this will be vice versa. So this will be generally, this is like the controller will affect the final control element, which affects the process. So this is something like this. Now, what is my question is, to get a response of minus DZD here, what should be this one? What should be this one? So this is plus, this is minus, this is negative feed forward. So the next question is, what are the transfer functions? What are the transfer functions G1 and GC, so that the response from the process is minus DZD. So this is the question. So can you solve what is G1 and GC, so that why 0? Y has to be 0. Then only you will have a steady state, no? What is the deviation variable at steady state? 0, no? This is capital Y. Now let's put variables here. This is, let's say, A, this is, let's say, B, this is C, this is D should not be there. This is E, this is F, this is H. Now what is B? B is nothing but R into G1. A is nothing but D into Gm. C is nothing but A minus B. What is rest values? E is equal to C into Gc. F is equal to E into Gf. H is equal to F into Gp. H is equal to this is. Now just let's put all the values. H is equal to F into Gp. What is F? E into Gf Gp. What is E? C into Gc Gf Gp. What is C? A minus B into Gc Gf Gp. What is A minus B? What is A? D into Gm. What is B? R into? Finally, right? What is H? Is equal to H is equal to A minus B into Gc Gf Gp. What is A is D into Gd minus R into G1 Gc Gf Gp. But this H should be equal to, this should be equal to minus dgd. This should be equal to minus dgd. So then what do you get? dgm. So this, sorry, here there is one correction. So in this one, this signal should be YSP minus DGD. So that minus DGD, DGD will cancel, Y is equal to YSP. So Y is equal to YSP, not 0. Y is equal to YSP or 0. If you take R YSP, or let's say in our, this is, take this as, let's say, YSP or 0. If you assume that, let's say it is steady state, Y is equal to YSP. Here also take it as YSP. So this is here YSP minus DGD. Sorry, here C should be B minus, you know. Here C is B minus A. I think there is one correction here. This is B minus C. This should be plus, this should be minus. Plus minus. This should be plus, this should be minus. Plus minus. Let's follow again. So I'll put the so sign of DC entering the junction box should be positive, minus D into GM. So here plus plus, because both are acting together, no, on the process. Now you equate the coefficients now. G1, GC, GF, GP is equal to 1. So another one is GM, GC, GF, GP is equal to GD. So what does this give you is GC is equal to GD by GM, GF, GP. So this is what is GC. Now you put GC here, then what you get GM? What you get G1 is, if you put GC here, GF, GP will cancel, so you will get GM by GD. Just so basically this GC and G1 are the transfer functions which eliminates the disturbance. So write this problem. Just take 5 minutes time and review the entire transfer function and everything. Write this one. Write this problem. The process and disturbance transfer functions. The process and disturbance transfer functions for a given system are 2 by 2s plus 1 into 5s plus 1. The process and disturbance transfer functions for a system are given by Gp of s equal to 2 by 2s plus 1 into 5s plus 1, Gd equal to 1 by 2s plus 1 into 5s plus 1. The feed forward controller transfer function, the feed forward controller transfer function, the feed forward controller transfer function that will keep the process output constant, that will keep the process output constant for changes in the disturbance is. For changes in the disturbance is. So what is the process transfer function? Gd by Gm, Gf, Gp. Gm, Gf are not given 1 and 1. So Gd by Gp is 1 by 2. So if the process transfer function is 1, or if the controller transfer function is 1 by 2, it will reject all the disturbances which is coming into the system. Next problem. I'll just draw it again for not very clean. This is the control diagram given. Gp is equal to 5 by 2s plus 1. Gd equal to 1 by s plus 1 whole square. The transfer function of a perfect feed forward controller is. So here, what is the response? Here there is no set point. Why there is no set point? Suppose if you say that I want to operate my CSTR in the throughout the life at 60 degrees, then there is no change need of set point. No, directly y should be equal to 0. If y equal to 0, that means you will put directly y minus 60. That means your small y is equal to 60. So that is how some control loops doesn't have set points. That means if I, why do you need a set point? Suppose if I want to operate the reactor sometimes 60, sometimes 70, sometimes 80, then you need a set point. So if you never operate the reactor at 60 or 70, then you don't need a set point. Clear? Now, what is the signal here? D into GD. What is the signal that you should get here? Minus D into GD. So let's say this is D. So D into GC into GP, which is equal to minus D into GD. Clear? Here the signal should be minus DGD, so that DGD minus DGD will cancel. We will get y equal to 0. What is the signal? D into GC into GP. So DD will cancel. What is GC minus GD by GP? So what is minus GD by DP is 1 by 5 into S plus 1 minus. Sometimes in the question, suppose in the previous question, what is the transfer function that will keep the output constant is 1 by 2. Sometimes you may not find 1 by 2, you'll find minus 1 by 2. That means the one who is operating is a positive feed forward controller. Clear? So here, if you see, so here the answer is minus GD by GP. So directly you should never by heart the formula is what I'm trying to say. So I think so there is one table in Kaufner, let's say Stephanopoulos. What is the advantage and disadvantage of feed forward and feed backward? So maybe you can just read that. I'll explain in the next class. So I'll stop here. So with that one, syllabus is almost 100%